Hello, this is the chapter on acids, bases, and salts. So let's first of all take a look at the definition. Remember that if he asks you to define acid or base, acid is proton donor, base is proton acceptor. That's the definition. Now what does that mean? It means that when you have an acid and it reacts in a reaction, it donates or it gives H plus ions. So when we talk about a proton, we're not talking about what we call subatomic particle, the particle inside the atom. We are talking about an H plus ion. Why do we refer to it as a proton? Do you understand that? Hydrogen atom is something that has one proton, one electron, nothing else. So if it forms H plus ions, what did it do? It lost that outermost electron. So it's actually an atom that has just one proton in its nucleus, and that is why we refer to it as a proton. So when we ask what is the species that is being donated by the acid, the species is H plus ion. So acid is a proton donor. When we dissolve an acid in water, it ionizes or breaks up to form H plus ions. A base is a proton acceptor. So when it reacts, it takes the H plus ions from the acid, and that is because when you dissolve a base in water, it forms hydroxide ions, and the hydroxide ions, when they accept the H plus, they form water. So a reaction between an acid and a base would result in the formation of water. Okay, so acid is a proton donor, and we understand that proton is what? Proton is H plus ion. A base is a proton acceptor. Now, how do I know if something is an acid or a base? That is from the formula. The acid will always have an H at the beginning, or at the end if it's organic, but let's just stick to the H at the beginning. The base will always have an oxygen or a hydroxide ion at the end of it. So an acid is H something, a base is something OH or something O. Okay, so what is an alkali? An alkali is a base that dissolves in water. So if I have a base, some of them dissolve in water and some of them don't. If the base dissolves in water, it is called an alkali. So for example, you should know that sodium hydroxide is a typical alkali, because sodium hydroxide is a base and it dissolves in water. Now when we react an acid with a base, what forms is called a salt. So salts are ionic substances that are produced from the reaction of acid with base. You could have two different types of acid. The acid could be concentrated or could be dilute. This is when I add a small amount of water or a lot of water. So if something is concentrated, that just means that it has only a small amount of water added to it. When something is dilute, that means it has a lot of water added to it, and that could apply to an acid or it could apply to a base. So I could have concentrated base or dilute base, and it is the same idea. If I have a base and I put a little bit of water in it, it's concentrated. If I add a lot of water, it is dilute. Okay, there are two types of acids and two types of bases. So an acid is either a strong acid or a weak acid. A strong acid is one that will break up to form a lot of H plus ions. So if I have HCl, HCl is an acid. When I dissolve it in water, it ionizes. Ionizes means it breaks up into H plus and Cl minus. Now, because hydrochloric acid is a strong acid, all the molecules of HCl in the solution will break up to form H plus and Cl minus. This is a characteristic of the acid. So an acid like hydrochloric acid is a strong acid, and that means that it ionizes completely in solution to give lots of H plus ions. Other types of acids are weak. A weak acid will only ionize partially. What does that mean? CH3COOH is ethanoic acid. We will be talking about it a lot more when we talk about organic acids. For now, just know that ethanoic acid is CH3COOH. When I dissolve it in water, only some of the ethanoic acid molecules will break up to form H+ ions. So we say it ionizes partially to form a small amount of H+ ions, and that is the definition of a weak acid. So the acid is either strong or weak. Hydrochloric is strong, sulfuric is strong, nitric is strong. Things that are weak are like ethanoic or citric acid. I'll talk about pH in a minute, so let's just ignore the pH for now. Now, a base also may either be strong or weak. We said, how do I know if something is a base? If it ends with, for example, hydroxide ion. So something hydroxide would be a base. Now, sodium hydroxide is a strong base, and with the same idea, that means that when I dissolve the sodium hydroxide in water, all the molecules will break up, will ionize to form lots of OH- ions. But there are some bases that are weak. A weak base means it will ionize partially. So if I have ammonia molecules and I dissolve it in water, only some of the ammonia molecules will ionize to give just a small amount of OH- ions. So for now, know that things like sodium hydroxide, potassium hydroxide, calcium oxide, things like that are strong base. Ammonia is the only weak base that we deal with in this syllabus. Okay, what does that mean? Or how can we distinguish between these different types? They have, scientists, have chosen a scale to determine or to given to the acids and bases in order to indicate whether an acid is strong or weak, or a base is strong or weak. Now, this pH scale are numbers from 1 to 14, and sometimes we have 0 to 14. And we say, if something is a strong acid, I'm going to give it numbers 1 and 2 and 3. So if we say suggest a pH for hydrochloric acid, you can either say 1 or 2 or 3. This is whether it is concentrated or dilute. So if we say dilute, don't give it anything more than 3. It is still 3. pH of sulfuric acid is either 1 or 2 or 3. pH of nitric acid is either 1 or 2 or 3. This is because all of these are strong acids. But if I say suggest the pH of lemon juice or ethanoic acid or vinegar, we just said that ethanoic acid is an example of a weak acid. Do you remember the definition of weak acid? Weak acid means it will dissolve in water, ionize partially, so only some of the molecules will ionize to give H+ ions. Now, if he asks to suggest the pH of any of these, I would say 4 or 5 or 6. Not more, not less. So ethanoic acid should not have pH 2, for example, because it is not a strong acid, it's a weak acid. Now, if something is not an acid and not a base, we say it is neutral, and we give it a pH of 7. So what are the things that are neutral that we deal with? Water is neutral. Salt, like sodium chloride, is neutral, so we give it a pH of 7. Now, bases. Some bases are weak and some bases are strong. And we said things like sodium hydroxide, calcium hydroxide are strong bases. So if he says suggest the pH of sodium hydroxide, you can either say 11, 12, 13, 14. Not less than that. A weak base like ammonia will have a pH of 8 or 9 or 10. You have to know these things. You may be asked to suggest the pH of any of these solutions. So let's try a sample question. This question says concentrated hydrochloric acid is a strong acid. What is meant by strong and what is meant by acid? So strong means, we said, the strong mean contains a low proportion of water or is fully ionized. Remember that we said if something contains a low proportion of water, we don't say it's strong, we say it is concentrated. So a strong acid is something that is fully ionized when dissolved in water. Okay, we said what's the definition of acid? We said an acid is a proton donor. So my answer is D. Okay, the next one. Which one of the following pH values could be the pH of aqueous ammonia? Remember what did we say about ammonia? We said ammonia is a weak base, and a weak base will have pHs, we said 8 or 9 or 10. So my choice here would be pH 10. Okay, now if you've gone to the lab at any point and seen solutions of acids and bases, you would know that an acid and a base are both colorless solutions. So hydrochloric acid is a colorless solution. Sodium hydroxide is a colorless solution. If I have in one beaker I have acid and in another beaker I have base, how can I distinguish which beaker is which? I can add a little bit of indicator. So an indicator is a substance that has different colors in acids and bases. So if I have something, I put it in acid, it gives a color. I put it in base, it gives a different color, then that thing can act as an indicator. So what indicators do we talk about? We have 4 indicators in our syllabus. We have litmus paper, universal indicator paper, phenolphthalein, and methyl orange. So let's take a look at this. Litmus paper. Litmus paper is used to determine whether something is an acid or a base. It doesn't tell you whether it is strong or weak, it just says whether it's an acid or a base. It doesn't tell you what is the pH of the solution. So here I have 2 beakers. They are both colorless solutions. There is no way for me to determine by looking at them which one is an acid and which one is a base. But if I put litmus paper, and if you've seen litmus paper, it's a paper like this. Some of it is blue and some of it is red. So I have what we call blue litmus paper and we have red litmus paper. Now, if I want to determine if something is an acid and I put the blue, it will turn to red. Now, if I put the red, it remains red. So litmus paper is red in acids. So if it was originally the red one, it will remain red. If originally it was the blue one, it will turn to red. Okay, what if I put litmus paper in base? Litmus paper in base turns blue. So if it was originally blue, it will remain blue. If it was originally red, it will turn to blue. So litmus paper in acid is red, in base it is blue. Okay, so that tells me whether this is an acid or a base, but it will not tell me whether it is a strong acid, strong base, weak base. If I want to know exactly what type of acid or what type of base, I use what we call a universal indicator paper. The universal indicator paper is actually, originally it's yellow. But when I put it into the different solutions, it will take one of these colors. So if I put it in sulfuric acid, for example, it will be red. If I put it in lemon juice or ethanoic acid, something that's a weak acid, it will be yellow or orange. If I put it in water, it will be green. If I put it in ammonia, which is a weak base, it will have shades of blue up to the strong base, which is blue. So remember that universal indicator paper in strong acid and in strong base, it gives almost the same colors as litmus. So in strong acid it's red, in strong base it's blue. You have to remember that if I put it in something neutral, it gives what color? Neutral is pH 7, like water, so it gives green. If I put it in weak acid, it gives yellow or orange. And you're not required to know all of the shades of blue for the weak and strong bases. Okay, so red in strong acid, blue in strong base. You could call it purple if you like, but it's actually, we call it blue in strong base, green in neutral, yellow or orange in weak acid. Okay, now the other 2 indicators are liquids. So I have phenolphthalein and methyl orange, and this is what we use in something we're going to be talking about, which is titration. Now, each of these has different colors in acid or base or neutral, and you have to remember the colors. So if I put phenolphthalein in a base, like sodium hydroxide for example, it will give that color, which we call pink. In neutral or in acid, phenolphthalein is colorless. So you have to remember that. Phenolphthalein in a base is pink. In neutral or acid, it is colorless. Now what about methyl orange? Methyl orange is red in acid, yellow in a base, and when the solution is neutral, this is called methyl orange, so it is orange. Remember that it's called methyl orange because it is orange in neutral. But in base it is yellow, in acid it is red. You have to remember these colors. So let's try this. 4 different solutions are tested with universal indicator. Which solutions are acidic? Now, we said if something is an acid, it will be what color in universal indicator? It will either be red or yellow or orange. These are the colors that we had in universal indicator paper. So the ones that are acidic here are the ones that are red and orange. So that is the X and Z. Okay. Okay, let's talk about reactions of acids and bases. And the first reaction that we have is called neutralization reaction. Neutralization reaction is a reaction between acid and base, and this gives salt plus water. So if I have something like acid, like what? Like HCl, for example, hydrochloric acid. A base like sodium hydroxide. Now, what would be the pH of the acid? We said HCl is a strong acid, so its pH is either 1 or 2 or 3. Sodium hydroxide is a strong base, so its pH is 11, 12, 13, 14, any one of that. And when they react together, what do they give? They will give sodium chloride plus water. That's my salt. So the salt, sodium chloride, is actually what we call salt. Sodium chloride is the salt that we add to our food, but it is, we call it salt, but actually it's only one type of salt. So anything that is formed from acid and base is called a salt. So what is the pH of the salt? It's 7. What is the pH of the water? It's 7. That means I have changed solutions that were originally acidic and basic into neutral solutions, so we call that neutralization reaction. Okay, what about acid plus metal? Now, if I react acid with a metal, what comes out is still called a salt, but this is a salt plus hydrogen gas. So if I have zinc with hydrochloric acid, for example, zinc, when it reacts with hydrochloric acid, it forms zinc chloride, and I'm left with what? I'm left with hydrogen. So remember, acid plus base gives salt plus water. Acid plus metal gives salt plus hydrogen. Okay, what about acid plus carbonate? Acid plus anything carbonate would give a salt plus carbon dioxide and water. So, for example, if I have hydrochloric acid with calcium carbonate, hydrochloric acid with calcium carbonate should give something plus carbon dioxide plus water. So what is that something that is left? It's calcium chloride. Okay? Okay. Base, the only reaction that we're going to talk about is a base with ammonium salt. So a base with an ammonium salt, you should know, will give ammonia gas. And when we talk about, there's a reaction that we will talk about later when we talk about test for ammonium. If I want to know if something is an ammonium salt, I can add a base like sodium hydroxide, for example, and this gives ammonia gas. You don't worry about this reaction. It just gives the salt plus ammonia plus water. Okay. Okay, the other reaction is if I have ammonia. We said ammonia is the only weak base that we're talking about anyway. So ammonia plus acid, what happens? What is formed is called ammonium salt. We know that ammonia is a base, and we just said that base plus acid should give salt plus water, but ammonia is the only base that we're talking about that doesn't have OH. We said a base is either something that ends with O or with OH, but ammonia doesn't have any oxygen in it, so there is no way I'm going to get water from this reaction. So ammonia plus acid actually gives just salt. Remember, ammonia plus, for example, hydrochloric acid will give ammonium chloride. Ammonia plus nitric acid will give ammonium nitrate. Ammonia plus sulfuric acid will give ammonium sulfate, and so on. Ammonia plus phosphoric acid will give ammonium phosphate, and of course we check the valences of each of them. Okay, let's try this sample question. Which property is shown by the alkali sodium hydroxide? So we said what is meant by alkali again? We said an alkali is a base that dissolves in water. So sodium hydroxide is a base. So which of these would be correct? It has a pH less than 7. What did we say about a base? No, a base will have pH more than 7. Okay. It produces a gas when it is warmed with ammonium chloride. Yes, sodium hydroxide is a base, and we said base plus ammonium will give ammonia gas. So this is actually my correct answer. Let's check the rest. It turns blue litmus to red. No, this is a base. A base will turn the red to blue, not the other way around. Okay, it turns universal indicator green. No, this is a base, so it should turn universal indicator blue. Green is for neutral. Okay, so let's try this question with 5 marks. Describe the reactions of hydrochloric acid with calcium oxide, magnesium, a named indicator of your choice. So you're supposed to explain what will happen if you react hydrochloric acid with calcium oxide and hydrochloric acid with magnesium, and if you put a certain indicator in the hydrochloric acid. So you should realize that reaction of hydrochloric acid with calcium oxide, this is a reaction of acid with base, so this is a neutralization reaction, and this forms calcium chloride and water. Now if I put hydrochloric acid with magnesium, what is formed? Magnesium chloride and hydrogen gas, so I will see bubbles of hydrogen gas. Remember that any reaction that gives out a gas, if he says what is observed or what do you see bubbles of gas. Now if I put hydrochloric acid, which indicator did we choose here? We chose phenolphthalein. If I put HCl, that's an acid, with phenolphthalein, it forms what color? Colorless solution. What if I had chosen methyl orange? Do you remember the color of methyl orange in acid? What was the color of methyl orange in acid? We remember methyl orange is red in acid. Okay, so let's try this question. 3 chemicals were each dissolved in water. The table shows some of the reactions of these solutions. So let's look at P. What did he say about P? With carbonate, it gives off a gas. So P is an acid or a base? P, we said, what is the substance that will react with carbonates to give out a gas? It's acid. So P must be an acid. So acid means its pH could be 2 or 7 or 13. Acid means it must be 2. So my answers should be A or B. Okay, so remember, an acid with a carbonate gives carbon dioxide gas. With ammonium, an acid will not react with ammonium. Which one reacts with ammonium? Ammonium, we said, reacts with a base to give ammonia gas. Okay, so we've decided that P is an acid. Now what about Q? Q, when I put it on carbonate, no reaction. That means it is not an acid. But when I put it on ammonium something, a gas evolved. So Q must be a base, because a base reacts with ammonium to give ammonia gas. So Q is a base. So base is which pH, 7 or 13? We've already decided that it's A or B. So I want a base, so a base is pH 13. So my answer must be B. Let's check R. R, no reaction with carbonate, so it's not an acid. No reaction with ammonium, so it's not a base. So it is something neutral, so that is correct. My answer is B. Okay. So what is a base? Do you remember the definition of a base? A base is proton acceptor. That is what you're supposed to write. Write the balanced equation for the reaction between ammonia and sulfuric acid. Do you remember how to write equations? Remember that all chapters from now on will be dealing with equations. So the chapter on equations is actually a basic chapter that you have to know for sure so that we can answer questions in any other chapter. So ammonia and sulfuric acid. Ammonia, you remember how do we write ammonia? Ammonia is NH3. Sulfuric acid is H2SO4. And we said when we have ammonia with an acid, it gives ammonium something. So ammonia with sulfuric will give ammonium sulfate. Remember, valency of sulfate is 2. And then to balance, I need 2 in front of the ammonia. Okay, so just the chemical equation for the reaction between sodium hydroxide and carbon dioxide. Now, sodium hydroxide is a base, and we said a base, when it reacts with something, that thing must be acidic. And actually that is correct. Carbon dioxide is an acid. So when it reacts with it, it will form sodium carbonate plus water. And then you balance. Okay? Okay. Let's try this one, which reaction is a neutralization reaction. Remember, we said, what do we mean by neutralization reaction? Neutralization reaction means acid plus base. So, which of these is a neutralization reaction? Silver nitrate, is that an acid, base, or salt? No. If it's an acid, it should start with H. If it's a base, it should end with OH or O. This is a salt. So A is not a neutralization reaction. What about B? B is calcium carbonate breaking up. This is called a decomposition reaction, not a neutralization reaction. C, sodium is not an acid or a base, so it's not C. D, I have sodium hydroxide, and that is a base. We said sodium hydroxide or any hydroxide is a base. Plus sulfuric acid, so that gives salt and water, so that is what we call a neutralization reaction. Okay. Okay. Which one of the following pH values is the pH of an aqueous solution of sodium hydroxide? Remember that we said sodium hydroxide is something that has a pH of 11, 12, 13, 14, so my choice would be pH 13. Okay, he says a mixture of sodium hydroxide and ammonium sulfate is warmed gently. What is the name of the gas produced? Remember we said base plus ammonium will give ammonia gas. Complete the following equation to show that hydrazine acts as a base. So hydrazine is something we haven't studied, but it is something that is similar to ammonia, N2H4 plus water. Now, if I react it with water, then it will form ammonium. It's just like ammonium hydroxide. If I say ammonia in water, it's ammonium hydroxide. So hydrazine in water will be this N2H5 plus NOH minus. Okay, write a chemical equation for the reaction between magnesium carbonate and dilute nitric acid. Remember that we said any carbonate with acid should give what? A salt plus carbon dioxide plus water. So magnesium carbonate, remember valency of magnesium is 2 and valency of carbonate is 2. Plus nitric acid is HNO3. So this gives magnesium nitrate, and magnesium is a valency 2, so I have to put 2 under the nitrate. Nitrate is valency 1, so I don't put anything under the magnesium. And we said carbonate plus acid will give carbon dioxide plus water. Now, please remember that you never leave an equation without balancing it. So this needs to be balanced, so I put 2 in front of the nitric acid. Okay? No reaction should be left without balance. Okay, so I said that something that has O or OH should be a base. Something that has H at the beginning is an acid. But actually that is not completely true. So oxides or hydroxides. So we're talking about oxides now. Some oxides are actually acidic, some oxides are basic, some oxides are amphoteric, some oxides are neutral. Now what does that mean? If I say that something is acidic, that means it will react with a base. If I say that something is basic, then it reacts with an acid. Now if something is an amphoteric, if we say something is amphoteric, the word amphoteric means it can react with both acid and base. Okay? If something is neutral, then it does not react with acid or base. Following? So an acid reacts with a base reacts with an acid. Amphoteric can react with any of them, and neutral does not react with any of them. Now, which oxides are acidic, basic, amphoteric, neutral? Remember that oxides of most non-metals. Non-metals are where in the periodic table? Non-metals are on the right side of the periodic table. So oxides of most non-metals are acidic. Carbon dioxide, nitrogen dioxide, sulfur dioxide, sulfur trioxide, silicon dioxide, all of these are acidic. Acidic means, first of all, if they dissolve in water, they form acid and they will react with a base. Now, so oxides of most non-metals are acidic, but there are some exceptions. Some oxides of non-metals are neutral. Can you see where neutral is? Which ones are neutral? Carbon monoxide is neutral. So carbon dioxide is acidic, but carbon monoxide is neutral. Neutral means doesn't react with acid, doesn't react with base. Nitrogen dioxide is acidic, but nitrogen monoxide is neutral. So NO is neutral. Neutral means doesn't react with acid or base. Of course, the oxide of hydrogen is neutral, because oxide of hydrogen is what we call water, and that is neutral. Okay, so oxides of most non-metals are acidic, except carbon monoxide, nitrogen monoxide, H2O. These are neutral. Okay, what about the basic? Which ones are basic? Oxides of most metals are basic. So calcium oxide, copper oxide, magnesium oxide, sodium oxide, all of these are basic. Basic means if they dissolve in water, they will form hydroxide ions. But there are some exceptions. Some are not basic, they are amphoteric. So which ones are amphoteric? You're supposed to know these examples. Oxide of zinc, oxide of aluminium, oxide of lead. These are amphoteric. These are the examples we're required to know. Zinc oxide, aluminium oxide, lead oxide are amphoteric. Amphoteric means they will react with acid and they will react with base. Okay? So, magnesium oxide is basic. If I dissolve it in water, it forms magnesium hydroxide. Carbon dioxide is acidic. If I put it in water, it forms an acid. And you should know that when you dissolve carbon dioxide in water, the acid formed is carbonic acid. Sulfur dioxide in water, this forms sulfurous acid. Sulfur trioxide plus water forms sulfuric acid. Are you paying attention? Sulfur dioxide and sulfur trioxide are both acidic. But sulfur dioxide will dissolve in water to form which acid? Sulfurous, H2SO3, while sulfur trioxide will dissolve in water to form sulfuric acid, H2SO4. Okay, so let's try this. The oxide of element X forms a solution with pH 4. So oxide of X, I dissolve it in water, it forms pH 4. Is pH 4 acid or base? Acid. So oxide of X is acidic, so X must be a metal or a non-metal. Which one did we say the oxides are acidic? We said oxides of non-metals are acidic, so X must be a non-metal. Now, oxide of element Y forms a solution that turns universal indicator blue, and that means that Y is, the oxide of Y is a base. When it turns universal indicator blue, it's a base. So the oxide of Y is a base, and we said oxides of what are basic? Metal or non-metal? Metal. So my answer is C. Which oxide is amphoteric? Remember we said which oxides are amphoteric? The examples that we had were aluminium, zinc, lead. Aluminium, zinc, lead. So aluminium oxide is amphoteric. What about the others? Let's see the others. What is calcium oxide? This is oxide of a metal. And we said oxides of a metal are basic. Carbon monoxide. What did we say about carbon monoxide? Is it acidic, basic, amphoteric, or neutral? Carbon monoxide is neutral. What about sodium oxide? Sodium oxide is an oxide of a metal. Oxide of a metal. If it's not amphoteric, then it is a base. So sodium oxide is a base. Okay, which statement describes the chemical property of aluminium oxide? Okay, what is aluminium oxide again? Aluminium oxide is what? Acidic, basic, neutral, amphoteric? Aluminium oxide is amphoteric. You should remember, we said which ones are amphoteric? Oxides of aluminium, zinc, lead. So aluminium oxide is amphoteric. What did we say about amphoteric? It means what? It reacts with what? You should remember that amphoteric means it reacts with both acid and base. Okay? Methyl orange turns red in the solution formed when substance R reacts with water. Again, R in water forms a solution that turns methyl orange red. When does methyl orange turn red? In what? In a basic solution, right? Methyl orange is red in in an acidic solution. Methyl orange turns red in an acidic solution. So which of these is acidic? Calcium oxide, potassium oxide, sodium oxide, sulfur dioxide? Yes, sulfur dioxide is acidic, so it is D. Okay? Okay, how do we prepare salts? The method used depends on the type of salt and its solubility. We're going to say that there are three types of methods, or three methods to prepare salts, and the method that we're going to choose depends on whether the salt I'm using is soluble or not soluble, and what I'm starting with is soluble or not soluble. So before we decide, we have to remember which substances are soluble and which substances are not soluble. So you have to remember that all nitrates are soluble. Compounds of sodium, potassium, and ammonium are soluble. So sodium something, sodium salt, potassium salt, ammonium salt, these are soluble. All acids are soluble. Barium chloride, magnesium chloride, calcium chloride, these are soluble. Copper sulfate is something that we use a lot in the syllabus, and you should know that it is soluble. Okay, most carbonates are insoluble. So barium carbonate, calcium carbonate are insoluble. Silver halide, silver chloride, silver bromide, silver iodide, all of these are not soluble in water. So they form a precipitate when they're formed in a reaction. Lead chloride, lead bromide, lead iodide, all of these are not soluble. Barium sulfate, we're going to be talking about it, is not soluble. Copper oxide is not soluble. You should actually know that copper oxide is a black solid. And of course, all metals do not dissolve in water. So this is basic, you need to know. So to prepare a salt, we need to decide, are we going to use a method called titration, or a method called neutralization, or a method called precipitation? So when do we decide on each of these? We choose titration if we're trying to prepare something soluble and we're starting from soluble reactants. So everything we're talking about is soluble, then we're going to choose titration, and we'll talk about what does that mean. If we're trying to make something that is soluble, but what I'm starting with is not soluble, then I'm going to choose a method called neutralization. Remember, this is the name of the method, not the name of the reaction. We talked about neutralization. Reaction is a reaction between acid and base. Well, here this is the method, the name of the method. Okay, precipitation. Precipitation is a reaction in which what is formed is not soluble. So when what is formed is not soluble, it comes down and it's called a precipitate. So this is called precipitation reaction. So let's talk about each of these. Now, what if I'm trying to prepare sodium chloride crystals? Okay, so the first thing I ask myself, is sodium chloride soluble or not? We said that compounds of sodium, so salt of sodium, are soluble. So sodium chloride, sodium anything is soluble. Okay. Then the next question I'm going to ask myself, which acid and which base should I use to make sodium chloride? So I need sodium something, so I need sodium hydroxide, and I need something chloride, so hydrochloric acid. Now, are these soluble or not? We said sodium anything is soluble, so sodium hydroxide is soluble. All acids are soluble, so HCl is soluble. So all of these are soluble to soluble, and the method we're going to use is titration. So basically, if I put sodium hydroxide base on hydrochloric acid in a beaker, I should end up with sodium chloride and water. But the problem is, how much sodium hydroxide should I add to how much HCl in order not to have any of them excess? I don't want to add too much. The word excess means too much or more than needed. So I don't want to add too much sodium hydroxide, because if I add too much sodium hydroxide, I will end up with sodium chloride plus the extra sodium hydroxide. I don't want to add too much acid, because I will then end up with sodium chloride plus extra hydrochloric acid, which I am not going to be able to separate. So the first problem we meet is, how much should I add? In order to know how much I should add, I do what we call titration. In titration, I use two main things. I use a burette, and the burette, remember, is the one that has graduations with a tap. And I need a pipette. Do you remember what a pipette looks like? It's a smaller apparatus, and it is used to measure a certain volume of solution or liquid accurately. So for example, a pipette is used to measure, for example, exactly 25 centimeter cubed. You cannot use it to measure anything else. Okay, so what are we going to do? First of all, we're going to fill the burette with the acid. You could put acid or base, but usually we put acid in the burette and base in the conical flask. So the first thing we're going to do is fill a burette with the acid, and then I want to put a specific amount of sodium hydroxide solution into the flask. So I put that using a pipette. So we put 25 centimeter cubed of sodium hydroxide solution in a flask using a pipette. And we have acid in the burette, or we fill the burette with acid. And our next problem is that all of these solutions are colorless. How will I know if I have added enough? So I need to add indicators. So for example, I could add 3 drops of phenolphthalein to the flask. So now in my conical flask, I have 25 centimeter cubed of sodium hydroxide, which I put with a pipette, and 3 drops of an indicator. This indicator could either be phenolphthalein or methyl orange. You cannot use universal indicator. You cannot use litmus. You have to use phenolphthalein. Okay? And remember that when I put phenolphthalein on sodium hydroxide, which is a base, phenolphthalein in a base will have what color? Pink. So the solution turns pink. Now I'm going to add dilute hydrochloric acid from the burette, drop by drop, gradually, until what? Until I want the solution in the flask to become neutral. What is the color of phenolphthalein when it is neutral? It's colorless. So I add dilute hydrochloric acid gradually from a burette until the solution in the flask turns colorless. Now I note the amount of acid used. How much did I need? For example, I needed 20 something here. I needed 27 centimeter cubed, for example. So now I know that if I put 25 centimeter cubed of sodium hydroxide, I will need 27 centimeter cubed of the acid. Now I'm going to throw away this flask because it has indicator in it. I don't want a solution that has indicator in it. And I'm going to repeat the reaction by adding the required amount of acid. So now I know that I need 27, so I'm just going to put 27 on the 25 centimeter cubed of sodium hydroxide without using indicator. So in that case, now I know that I have in my flask a solution of sodium chloride in water. How do I get pure dry crystals from that? I heat the solution to point of crystallization, cool, this will form crystals. Then I need to filter the crystals from the solution, wash the residue or wash the crystals with a few drops of distilled water, and dry between filter papers. Remember that in any of our experiments, when we want to dry the crystals, we dry them between filter papers. We do not put them, for example, in an oven or things like that, to avoid breaking up of the crystals. Okay? Okay. So this is how we do the titration. We had the flask and we added until the pink color just disappears or forms a colorless solution. So let's try this question. Aqueous ammonium phosphate can be made in the laboratory by reacting aqueous ammonia with aqueous phosphoric acid. Again, I'm going to remind you that the word aqueous means dissolved in water. Okay. Okay. So the first question here says, state the name of the piece of apparatus labeled A. What is the name of A? Again, we said A is something that has graduations, and at top, A is called burette. Suggest the pH of phosphoric acid. Well, let's think. Phosphoric acid is what? You should remember that phosphoric acid is a strong acid. A strong acid means its pH could be 1 or 2 or 3. So choose any of them. So let's say pH 2. It cannot be more than that. Describe how the pH of the mixture in the flask changes as the acid is added. Remember, what would be the pH of the ammonia originally in the flask? Ammonia has a pH of what? We said ammonia is a weak base. So it should have a pH of 8 or 9 or 10. Now when I add acid, what is the pH of the acid? The pH of the acid is 2. And I'm trying to add it until it becomes neutral. So actually the pH in the flask should change from either 8 or 9 or 10, and it should go down to about pH 7 because I need it to be neutral. So the pH is decreasing. Okay? Okay. This is a kind of experiment which we have at the end of paper 6. And this is usually a question with about 6 marks, 5 marks, 7 marks sometimes. Okay. Oven cleaners contain an aqueous solution of sodium hydroxide. So he's telling me that oven cleaners are solutions of sodium hydroxide. Okay. Plan an investigation to show which of the two different oven cleaners contains the more concentrated solution of sodium hydroxide. So basically, you're given 2 solutions of sodium hydroxide and you want to know which of them is more concentrated. So he's not telling you to prepare a salt here, but he's just telling you to find out which of the sodium hydroxide solutions is more concentrated. Well, let's think. If I do titration with an acid, the one that is more concentrated is the one that will do what? Is the one that will need more acid to be neutralized, right? If I'm adding an acid to a base, if I have a concentrated base, then I will need more acid. If I have a less concentrated base, I will need less acid. So basically, you're describing titration. So what are we going to do? We have sodium hydroxide solutions, 2 different sodium hydroxide solutions. So we're going to use the first one, for example, do titration, and then the second one, do titration and determine which of them needs more acid, right? So how do we explain that? So how do we do titration? We said we put 25 centimeter cubed of the first sodium hydroxide solution into a flask using a pipette. Add 3 drops phenolphthalein. The solution turns pink. So we're doing a typical titration. Okay. Add dilute hydrochloric acid from a burette until the pink color disappears. Note the volume of acid used. And then we're going to repeat the same thing using 25 centimeter cubed of the other alkali solution. The one that uses more acid is more concentrated. Do you understand how to explain this? First of all, when we explain these experiments, we need to explain them in detail, mention all the apparatus, mention what is the same. What are we keeping the same? For example, here, in order to compare between the 2 oven cleaners, I have to use same volume of the 2 oven cleaners. So I'm going to use 25 of the first one and 25 of the second one. And everything else is the same. And the only difference is how much acid they will use. Okay? Okay. We can use titration for something else. So if we have solution A and solution B, so I have a certain volume of, a certain solution of HCl in the burette, and I have 2 solutions. So this is what we were just doing. I'm using titration to determine which solution is more concentrated. So if I have the acid in the burette, and then I add some acid for solution A, to neutralize solution A. I need another acid, another volume of the acid to neutralize solution B. And we said, which of these is more concentrated? Well, the one that will use more acid is more concentrated. So A is more concentrated. Okay? But in another kind of experiment, he could put two different acids in the burette, and the solution in the flask is the same. So if I put two different acids, once I do it with acid A in the burette and once I do it with acid B in the burette, and I'm using it to neutralize the same solution of sodium hydroxide, the same solution of sodium hydroxide. So if I do the titration with acid A and I need a lot of acid A, does that tell me that A is concentrated or dilute? If I need a lot of something, that means it's not really concentrated, that means it's dilute. If I need less of acid B, I needed only a very small amount of B to neutralize the base, that means that B is more concentrated. So, yes, B is more concentrated. Okay? Or A is less concentrated. Do we understand the idea? So if the ones in the flask are the same, then if I need more of the acid in the burette, then it is not as concentrated as the other one. But if I have different solutions in the flask, then different solutions in the flask, and the solution in the flask requires a lot of the acid, much more than the other one, then the one that requires more of the acid is the more concentrated. Am I confusing you completely? Think about it, it's reasonable. Okay? Okay. The other method is neutralization. And neutralization, we said, we use this method that I'm going to describe if we're starting with something that's not soluble. So, for example, I want to make copper sulfate. You should know that copper sulfate is soluble. But how can I make copper sulfate? I can make it from acid plus base. Now, which acid and which base should I use? I need copper sulfate, so I need sulfuric acid. If he was telling me to prepare copper chloride, then I can start with hydrochloric acid. If he's saying copper, I don't know, phosphate, then I will start with phosphoric acid. You understand the idea? So I'm trying to make copper sulfate, so I need sulfuric acid. Plus what? I want you to remember that I can either make a base with an acid or a metal with an acid. But remember that copper metal does not react with acid. So we said metals with acid would give salt plus hydrogen, but metals that are more reactive than hydrogen. So I will tell you for now that copper alone will not react with acid, so I have to use copper oxide. Copper oxide is a solid, so I cannot do titration. So I need a different method. So the method that we use is neutralization. Now, how do I do neutralization? I get sulfuric acid in a beaker and I start adding copper oxide, which is a solid. Of course, when you're adding a solid to a solution, you use a spatula. Do you understand the meaning of spatula? It looks like a spoon. It's not a spoon, it's a spatula. So we add copper oxide to the solution in the beaker until what? Now, when I'm adding the copper oxide to the sulfuric acid, it will form copper sulfate. And you should know that copper sulfate is soluble. That means the copper oxide will dissolve to form copper sulfate. Now, I add a little bit more of copper oxide, it will dissolve. I add a little bit more of copper oxide until what? Until all the acid has been used up. So once all the acid has reacted and I add some more copper oxide, there is nothing for it to react with. So the extra copper oxide will remain in the beaker. So we call that excess copper oxide because this is more than we needed. Okay? So we add basically copper oxide to the sulfuric acid in the beaker until what? How do I know if the reaction has finished? Until excess solid remains in the beaker. Now, what should I do next? Now, I know that my solution has the copper sulfate and water, and I have excess solid at the bottom of the beaker, so I need to filter the solution. when I filter the solution, what is in the filter paper? The one in the filter paper is the excess copper oxide that I don't really need. And what I need is my copper sulfate solution, right? So the copper sulfate solution, I need to take it and make crystals from it. How do I make crystals? Heat the filtrate to point of crystallization, cool, filter the crystals. If you want it pure and dry, I should say wash with a few drops of distilled water and dry between filter papers. Okay, so we add the solid copper oxide until, using a spatula, to 25 centimeter cubed of sulfuric acid in a beaker until excess solid remains in the beaker. Filter to remove the excess solid. So why are we filtering? To remove the excess solid. Now we take the solution and we heat to point of crystallization, cool, filter the crystals. So this method is called neutralization. Okay? Okay, let's try this question. A salt is made by adding an excess of an insoluble metal oxide to an acid. How is the excess metal oxide removed from the mixture? How did we remove the excess solid? By filtration, right? Okay, another method is titration. Precipitation. Precipitation is a method in which you are trying to prepare something that does not dissolve. So you're trying to prepare an insoluble salt, and that means when you put two soluble solutions on each other, they will form what we call a precipitate. Do you understand the difference between precipitate and excess? In the previous reaction, we had excess solid. So let's go back to here we had the copper oxide here. I added it until it was excess. So the solid in the beaker there is called excess because it is just extra solid that I added. But here, when I put two solutions and they form a solid, that solid is called a precipitate. Okay, so I'm trying to make what? I'm trying to make silver chloride. Now, the question is, what am I going to use to make silver chloride? I need silver something and something chloride. Okay, silver something has to be soluble. I need to start with something that's soluble. So silver, what is soluble? You should remember that all nitrates are soluble. So silver nitrate is an aqueous solution. Okay, I want something chloride. We said anything, any compound of sodium, potassium, ammonium is soluble, or acid. So actually you could put sodium chloride, or you could put any of the other substances that are soluble. Now I put the two solutions on each other. When I put the two solutions on each other, I get a precipitate. So the silver chloride forms as a white solid at the bottom of the container, at the bottom of the flask. This is called a white precipitate. Now, what do I want? I want this white precipitate, so I filter it, and the residue in the filter paper, that is what I want. That is the silver chloride I'm trying to make. So I just wash this. I don't do any crystallization here because I don't want the filtrate. The filtrate is sodium nitrate solution. I don't want sodium nitrate. I want the silver chloride, which is the white solid that remains in the filter paper. So I just wash the residue with a few drops of distilled water and dry between filter papers. Are we following? Okay, so let's try this question. Which two processes are involved in the preparation of magnesium sulfate from dilute sulfuric acid and excess magnesium oxide? Okay, which method is this? The first question I ask myself, which method is this? I'm trying to make magnesium sulfate, and I'm starting with magnesium oxide, and he's telling me I'm going to use excess. Magnesium oxide is a solid. That means I'm using the method called neutralization. So neutralization, and then after that, what should I do? I should do filtration. Okay, so he's talking about the neutralization process. Which method is used to make the salt copper sulfate? How did we make copper sulfate? We made copper sulfate from acid and what? I can I use alkali to make copper sulfate? We said copper sulfate, we're going to use what to make copper sulfate? We said, first of all, I will need sulfuric acid, so I will need the dilute acid. We said sulfuric acid plus what? In the experiment I explained, we used copper oxide. We said I cannot use only copper because copper does not react with acid. So I cannot say dilute acid plus metal. So C is wrong. And we're not talking about a non-metal oxide. We're talking about copper oxide. So that would be a metal oxide, not a non-metal. So D is wrong. So I have to choose between A and B. So I'm reacting copper what? I can either use copper oxide or actually I can use copper carbonate to react it. Okay, so copper carbonate or copper oxide plus acid will give copper sulfate. Okay, so let's try this question. The diagram shows the steps in preparation of a salt. Which salt is prepared by this method? Okay, well, let's take a look at which method is he doing. He's crushing something and then he's adding it to something in a beaker and then he's filtering and taking the filtrate. So which method is this? It's definitely not titration. Titration would use a burette and a flask and so, things like that. And now, is it neutralization or precipitation? Remember that in neutralization I take the filtrate. In precipitation I take the residue that is in the funnel. So this is obviously a neutralization reaction. Now the question is, which of these salts can be prepared by neutralization reaction? Well, let's look at them. Barium sulfate. What is barium sulfate? Soluble or not soluble? Barium sulfate is not soluble. So, and we said to prepare a salt that is not soluble, I use precipitation. So this is not neutralization. Now, to make copper sulfate, yes, we said we make copper sulfate from copper oxide, which is a solid, added to sulfuric acid, and then we filter and we take the filtrate. So yes, this method would be used to make copper sulfate. But what about the others? Potassium sulfate, sodium sulfate? No, potassium sulfate and sodium sulfate are both soluble. Remember we said potassium salts are soluble, sodium salt is soluble. So to prepare something that's soluble, I usually use, and potassium, I will start with anything also that's soluble, so this will be done by titration. Okay, we're at the end of this, and I would like you to study this chapter and try the questions so that we can discuss them in the next video. Okay, thank you.